Good evening, everyone. Let's do this. All right, so people are probably wondering what's going on. I thought Ebon was a flat earther. Why is he trying to debunk flat earth and prove globe earth? Well, the globe earthers aren't doing it very well. I go on Nathan Oakley's debates every once in a while, and we get pretty much trolls. There's no other way to say it. They'll just say, yeah, semantics. I don't care. I'm not using science. World is a sphere. Globe, it's a ball. It's like, I'm correct, you're wrong. No matter what you say. And it's like, no, we're just regurgitating your scientists. And they go, you're wrong. It's like, so you're wrong. It's like, no, you're wrong. No, you're wrong. It's like, it's pretty dumb. I mean, I'm glad that Nathan Oakley has it and everything, but the people who come on as globe earthers is they don't state their case very well. So I think I can do a better job of doing it. The only problem is, well, I've already done it once. Maybe I'll do it better this time. We'll see. All right, so let's start. Best way to start, in my opinion, is to let's Google it. Well, first thing you're gonna do when you're gonna go like, all right, let's finally look into flat earth. Let's debunk this nonsense, because look, it's like, this is the 21st century. Okay, we're gone to Mars. We've landed on the moon 6 out of 6 times, and that was like 2 generations ago. Like, that's old news. Hey, how's it going, Nathan? What link? Sometimes I don't catch everything on YouTube, especially if you send me a link in the in a response. So just know that if you do send me a link in a reply, in a comment on YouTube, I think that applies to everyone. It's going to be like held into a, let's see, it's going to be held into a queue of like comments for approval or something like that. I don't see it. Oh, okay, I see. Mark Sargent's gonna talk tonight. Oh, it's done. I never heard of Zuluon. I guess. I'll take a watch. It's about an hour 47 minutes. I'll take a look after. Thanks, Nathan. It's good to know. So let's continue. Let's look at the first one, okay? Big Think Top 10 2018. 3 proofs that debunk flat earth theory. All right, let's do it.
The rocket equation. It's a beautiful thing.
And again, you got NASA.
No astronaut launches through space with their finger.
Go Team NASA. Oh my goodness, is that another NASA astronaut? Okay.
So, Oscar, you asked the question, what are some of the easiest ways that you can prove that the Earth is round? Because apparently this is something that we're debating. I have no idea why. That's a hard thing for me to even start talking about, because there are so many proofs that the Earth is round, it's difficult to know where to start. And it's not okay to think that the Earth is flat. This is not a
It's not okay, folks. It's not okay. It's not okay, folks. It's not okay. It's not okay to think that the Earth is flat. All right. Just get to Michelle Thaler. Let's get to the point. I mean, there's so many. And you got 7 minutes. Let's go.
Viable argument. I have friends who have been on the International Space Station. They have orbited the Earth once.
Yeah, no one else has friends that have been to the International Space Station. You know, only astronauts get to the International Space Station. You know, the last time that they sent a civilian up into supposed space, it crashed. The Challenger explosion. Of course, the conspiracy theory is, well, they all survived. So yeah, why would they fake an explosion? Well, they don't want to send civilians up into space because last time that happened, it exploded.
Every 90 minutes. You know, I have had personal experience with people that have been up in space and can see with their own.
Okay, personal experiences, great. I don't have any personal experiences. Please get on with the proof.
Eyes that the Earth is round. And of course, we've taken all these amazing pictures from space. They're so beautiful, all those pictures of the Earth.
You know, and to have those negatives would be awesome. But unfortunately, NASA destroyed all those pictures and video footage. So what we've got are just digitized, updated renditions of those original photographs.
So I don't really know what's going on right now with this Earth is flat thing, but I will.
What's going on are you guys keep doing the same thing. You guys, look, all you have to do is look in my last video. Michelle Thaler, just look at my last video. You guys have space at your disposal pretty much. You guys make what, 51, not make. You guys use $51 million a day for your budget. And you can't prove to simpletons that the Earth is actually a globe. I mean, it should be simple. I could do it. Just make me director of NASA for one day. Actually, how long does it take to get to the moon? About a week? Yeah. You can make me a director for a week. I'll get it done.
Tell you that this is one of the things I really enjoyed teaching my own astronomy class about, because there are proofs all around you. It is not
minute 6. All right. You've already said that. Let's go.
Not difficult to know that the Earth is round. In fact, people have known this for way more than 2,000 years.
2,000 years. How did they know? They don't have planes, right? Like, do they have planes 2,000 years? Do they have spaceships in 2,000 years ago? Do they have photographs 2,000 years ago? Do they have videos from 2,000 years ago? How did they convince everyone in the world that the Earth was round 2,000 years ago?
The ancient Greeks actually had a number of really elegant, wonderful proofs that the Earth was a sphere. So let's start from the simple to the slightly more complicated.
Yeah, let's start with the simple. All right, finally, minute 23 seconds in.
One of the things you can see yourself with a pair of binoculars is if you
Did they have a pair of binoculars 2,000 years ago in ancient Greece? I mean, why are you talking about ancient Greece? But using today's technology with binoculars. I mean, at most, what, they probably have monoculars, telescopes?
actually go out to a lake, and there are boats on that lake.
Okay, this is gonna be, you're gonna see the curvature of Earth. All right, cool. Let's listen to this one.
The farther away a boat is, the more the bottom of the boat will disappear, and you'll basically just see the mast of the boat. And as a boat goes farther and farther away, the last thing you will see is the very top of the mast of that boat. And
so she's talking about the curvature of Earth, and the curvature of Earth that was calculated all right. How many miles can you see with the Earth curves? Life science. Let's see. It's 8 inches per mile squared, but okay. There you go. But, you know, we want to see the details. Okay, credit to Noah. On a clear day, you can see for miles and miles and miles. The old saying turns out to be true. For a 6-foot-tall person, the horizon is a little more than 3 miles away. Geometry tells us that the distance of the horizon, the furthest point the eye can see before Earth curves out beneath our view, depends simply on the height of the observer. For example, if you stood upon Mount Everest, which is 29,029 feet, the horizon would be about 230 miles away. And the effect of refraction, which bends rays of light as they pass through the atmosphere, and the horizon is even further. Cold weather increases the amount of atmospheric refraction, so in particular frosty locations such as Antarctica, people have been able to see hundreds of miles away. Really, people in Antarctica. I'd like to do that. Can I go to Antarctica to see hundreds of miles away? Oh, wait, I can't. Son of a bitch. Since the clouds hover above ground level, they can be seen further to farther distances than features on Earth's surface. But just as weather sometimes aids our view, it can also hinder it. Fog and light scattered can limit visibility to below what you can expect based on height. Blah, yada, yada, yada. Okay, let's go back to Michelle Thaler.
That's because the boat is actually going over the horizon that's curved. And that means that as it goes farther and farther away, you see less and less of the bottom of it and more of the top of that. You can see that with binoculars, by an ocean, by a lake. It's really easy. That wouldn't happen if the Earth were flat.
All right. Oh, God. You know who did a great video about that? PBS, Genius by Stephen Hawking. I mean, oh my gosh. Who else but the most famed theoretical physicist of all time, Stephen Hawking, I don't know, well, one of them, right? He's pretty much doing a little experiment. There you go. 3 random people. They're all not scientists, even though, you know, one has a twin sister named Kat Babino, who is a scientist, but this is Kat Babino, who's not a scientist. But here we go.
Yeah, I have you on the telescope. Go ahead and land. As it lands, it completely disappears.
Look at that. Stephen Hawking, awesome. He just pretty much proved a helicopter disappearing over the horizon. I mean, isn't that just debunked? Flat Earth debunked. Game over. So stop watching it from that point on.
Appears from my line of sight.
Because if you keep watching it...
Let me know when you can see us on spots of the horizon.
I got him. I got him.
Oh my goodness. Look. They filmed the helicopter disappearing over the horizon, and then they filmed the helicopter rising up from the curve of the horizon. Done. It's over. Debunked. Flat Earth is debunked. Ah, crap. Shit. Did I notice something there? Was there 3 birds that looked pretty much exactly alike? Here, let's keep going.
As it lands,
Wait a second. What the fuck just happened? Wait. Why are there 3 birds flying in the same formation? Left to right? I don't get it. It's like, is that like a glitch in the Matrix? That those birds, I think they're practicing just like the Blue Angels do. You know, they just need to fly in that pattern. Maybe those aren't 3 birds, but those are 3 Blue Angels. Oh, wait. Let's do a snapshot by snapshot of the 2 different scenes in the same show called Genius by Stephen Hawking. I mean, it debunks flat Earth. Number one proof that you're going to do. This is it. This is it. You had to go on and fake it. You had to fake it. Why? God damn it. I'm sorry, I shouldn't say that. It's not God that needs to be damned. It's the people who keep faking this shit. God needs to damn them, hopefully. He doesn't need to. Whatever. You know what I mean. Stupid sayings. That's why you shouldn't curse. Cursing is bad. Anyways, yeah. Well, that didn't quite debunk Flat Earth, did it? It kind of went the other way. I mean, when you have to use Stephen Hawking's name, a show that features Stephen Hawking, where they do a lot of scientific experiments and observations, well, that just didn't pan out right. And you think, okay, Ebon is a flat earther. He faked the... I edited all this. You know, I'm that good of an editor. I can go ahead and splice together a helicopter within a reticule going down and up. And, of course, I would... Yeah, sure. All right, so here we go. All right, those are all those little Little snapshots. Genius. If you're gonna watch a video debunking flat Earth and it's testing and showing the curvature, the things disappearing over the horizon, the curvature of the Earth, don't watch Genius by Stephen Hawking. Talking about, well, whatever you do, if you don't want to be a flat earther, you do not want to watch Genius by Stephen Hawking episode 6, Where Are We? You do not want to watch at the timestamp at 13 minutes and 11 seconds. You don't want to watch it at the 14-minute and 9-second mark. I mean, the links to the original video are in this description box. Whatever you do, do not get an Amazon Prime subscription. Whatever you do, well, that's true, but it's pretty cool to have. Whatever you do, do not watch those 2 video snippets going directly to that video and having it play back. Do not do it. Do not do it, because, well, we've got so many other proofs that the Earth is curved in a globe that we're just gonna let's just say this one was just it was just faked. Let's just no, it wasn't fake. Those 3, let's just say the 3 birds, the 3 blue angels ruined the experience because they happened to circle around and fly in the same formation, in the same direction, in the same opportune time where the helicopter was going above where it landed. I mean, gosh, I mean, how could 3 birds just ruin a scientific experiment like that? It's just mind-blowing. All right, let's go. Maybe let's look at the second proof this time.
You would simply see the boat getting smaller and smaller and smaller as it went farther away, but you'd be able to see the whole thing with the same proportions. Now, another way that you can tell that we're on a sphere is to think about how there's something called the tropics on the Earth. And the tropics are places near the equator of the Earth where sometimes the sun is overhead in the sky. And this was actually something that the Greeks used.
Oh, now she's going to talk about Eratosthenes. Oh, yeah. Let's talk about Eratosthenes. Let's have her finish.
Not only to prove that the Earth was round about 2,000 years ago, but they actually measured the circumference of the Earth accurate to within just a couple percent. 2,000 years ago, we've known that the Earth was round.
Not to mention, and I mean, goodness gracious, Michelle Thaler, how could you even not mention this? Not only did they know the circumference of the Earth and the radius of the Earth, the man Eratosthenes did it without ever leaving Egypt. I mean, it has to be true because, I mean, Wikipedia says it, right? Eratosthenes. All right. Oh, no. Where's the Wikipedia? There we go. Boom, 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 boom. Did he? Oh, not that one. Look at that. I am not. I mean, it's just, you can't make this shit up. Eratosthenes calculated the Earth's circumference without leaving Egypt. Who believes Wikipedia? I mean, everything else that Michelle Thaler says is true, right? It doesn't have to be Wikipedia. Oh, wait, Wikipedia. It's showing the exact circumference of the Earth, the radius, and all that stuff. Well, maybe sometimes, you know, how would people know? You know, maybe he did leave Egypt. It's just cooler to say that he never left Egypt in the first sentence. I mean, it would just be one thing just saying Eratosthenes calculated Earth's circumference, but I mean, you had to put in without leaving Egypt in there. It's like, why would you just add that in? Is it important in some way? Is it? I mean, why can't you just leave that out? Leave it up to some speculation, but of course, you know, I can measure the Earth's circumference, people, without leaving Columbus, Nebraska. You know how awesome that is? I just know that in the equator, when the sun's directly overhead at noon exactly, the sun is directly overhead and doesn't leave a shadow. Because someone told me. And just so you know, I didn't Skype, I didn't do Zoom, I didn't give a telephone call or anything like that. I had someone message me with the carrier pigeon. They wrote a little letter to me saying that was exactly what they saw. I don't know who it was. They just knew how to fly it over to Columbus, Nebraska. And that's how I know. I didn't have to leave Columbus, Nebraska. Oh, and also, to figure out the, after I use a sundial, and of course they call it a gnomon, that I just know that the degree of angle, right? I just need to divide it by 1/50. Just 1/50th the circumference of a circle. Where do I get that? Well, Aristarchus in 200 BC, or 270 BC, I'm sorry, 70 years before this measurement. Well, Aristarchus said that the Earth is a globe. How do we know that? Because he said so.
There was a really brilliant Greek scientist called Eratosthenes, and Eratosthenes noticed that there was a town called Syene, and on a certain date, the sun would actually shine straight down to the bottom of a well. That meant the sun was directly overhead. You could look down a well and see the sun shining back at you. And on the very same date, farther away in the city of Alexandria, that didn't happen. The sun was not directly overhead. It was a slight angle. And all that Eratosthenes did was he measured the difference in the angle of the sun. It was straight overhead in Syene. In Alexandria, it was a little bit less than overhead. And he rationed that that change in angle from one city to another was probably indicative of us being on a curved surface. And you could make all kinds of measurements.
Did you hear that? Let's repeat. Let's have her repeat that.
Syene. In Alexandria, it was a little bit less than overhead. And he rationed that that change in angle from one city to another was probably indicative of us being on a curved surface.
He rationed? He rationed. He rationed. What, he didn't... Why did he ration it? What was the evidence? Oh, I like hearing that again.
From one city to another was probably indicative of us being on a curved surface. Less than overhead. And he rationed that that change in angle from one city to another was probably indicative of us.
He rationed that it was probably... Do you hear those words, folks? He rationed that it was probably indicative. You know what this circumference of the Earth, the radius of the Earth, you know why it's important? Because it's involved in the calculation of gravity, not just by Newton, but by Einstein. Okay?
It's being on a curved surface. And you could make all kinds of measurements, even between those two cities, and see that the angles were different. The sun was at a different place in the sky. Using this, he actually measured the circumference of the Earth, and he got it right 2,000 years ago.
He got it right. Oh my goodness, he got it right. He figured it all out 2,000 years ago. He didn't need NASA. He didn't need planes. He didn't need binoculars. He didn't need telescopes. He needed 2 sticks. Heck, he didn't even need to leave Egypt. He just knew. I mean, one, he knew that the Earth was a globe. 2, he knew exactly what that there was no shadow exactly on the summer solstice. I'm sorry, he had to know the exact day. So the summer solstice, any other day would have made it null, and he had to have measured it at noon, because any time other than noon would have made a shadow. So he just had to do exactly at the summer solstice, and I wish he would have focused on that. Summer solstice at noon at the equator, no shadow directly overhead. Without ever leaving Egypt, he had to know all that. And then secondly, he had to do the exact same thing in Alexandria on a summer solstice at noon. Otherwise, it just would just not have a very accurate measurement, right? So there you go. You had to know exact time to do all this, exact places, you know, and just measure the difference using a sundial, and therefore divide it by the circumference of the Earth. And that was she put it very, very succinctly, I guess. Succinctly? Damn, I don't know. Anyways, that's that. Here we go. Let's keep going.
So another really simple proof is that
all right, so first one, 3 birds ruined the experiment because they made it look fake, right? So the first one, you want to see curvature. You want to see curvature over the horizon. But that curvature does not exist because 3 birds ruined the actual results. And therefore the curvature was ruined by people thinking that this was a fake edited video. Sorry, I can't do a good whatever impression that was. Second, let's see, Eratosthenes, without ever leaving Egypt, he assumed he knew exactly what would happen on the summer solstice at noon in the equator and at Syene and somewhere else, and then measured the angle of the elevation at noon in Alexandria, and therefore figured out, hey, the Earth is a globe, so let's divide that by you know, it's whatever. It's okay. So how does one in the year 200 BC, I mean, that's like 21, well, I don't know. Jeez. 2219 years ago. So 2219 years ago, what was it that convinced them that the Earth was a globe? Did NASA time travel? Is that what the entire quantum computers is about? Time traveling, so NASA can talk with Eratosthenes and Aristarchus and saying, hey, here's a photo of Earth. It's a globe. It's a globe. Here, see, I'm from the future. Earth is a globe. Just so you guys know, and we'll see you guys later. So that's what it is. The quantum computers that have been invented is to have someone send someone from NASA to show a photograph to Eratosthenes and Aristarchus, a picture of the globe Earth, and therefore they could come up with this equation so we know the radius of the Earth, so we can formulate gravity, and then eventually fly to the moon so we could take a picture of the globe Earth, so we can go back 2200 years again in that time whatever. Whew. You know, they gotta make a movie about this. All right. Okay, let's look at the third one. Third one should make more sense. I mean, obviously there's thousands of proofs that the Earth is a globe.
Any given date, at different cities and different places around the world, the sun is at different angles in the sky. That wouldn't happen if the Earth wasn't round. Then there are some other proofs.
Wait, what? Different angles? So the sun is at different angles, and therefore the Earth is round. You can't have different angles on the flat Earth? You know what I like? You know what I like? I like it that I like it when people say, we know that the Earth is round because when we look at the moon and the sun, it's a circle, and thus we know it's a ball. You know, if we saw the moon and the sun as a square in the sky, well, we would definitely know that it was a cube, even though we don't see the moon ever rotating, spinning. I mean, we don't even see it turning, right? Turning, spinning, whatever. We don't see the moon do that. We don't see the sun do that. We get shown pictures and stuff like that and all this other stuff. So how do we know that it's a globe when we only see one side of the moon? And we can't really see the sun. Not enough detail. It's too far away. There's no topographical things that you can see even with filters. The planets, can we see them with plain telescopes, like just ordinary people on the ground with multi-$1,000 telescopes? Do we see them? Do we see them doing that? Do we see them or like spinning? I don't. Do you? Maybe you know, you just need to have a couple $100 million telescope. Otherwise, you just wasted a couple $1,000 on a telescope that doesn't see jack shit. Jack whatever. Maybe I gotta stop cursing. All right, so apparently on a flat Earth, the sun can't be at different angles. I don't know how that works. Wait, you're an astronaut?
That are a little more obscure, but they're actually really lovely. And one is to observe what happens during a lunar eclipse. Now, a lunar eclipse happens when the Earth casts a shadow on the moon. The moon actually goes dark. In fact, if you've seen one, you can actually see the Earth's shadow go across the...
That happens only like 1 out of 6 times, that lunar eclipse, because, oh, crap. You know what? I wanted to observe something like that because you've got the sun, you've got the moon, in my head is the Earth. Obviously, it should always be a lunar eclipse, right? No, that does not happen. Why? I don't know, because it would be something that I would like to know. Here, you want to see something cool this morning? Or is today 21st? Yeah, it is today. Oops. All right. Let me do it again. That right there is the full moon. I know it's hard to see. Maybe I'll just get the other video out here. So we can see the full moon. See that? Ah, crap. Just look up in between those trees. That was the full moon. Oh, shit. See? You can see the right full there. Moon over here. It's faint, but you can see it. It's huge. It's a little bit harder to see today. You know that this is the Thursday, March 21 full moon. It's Thursday, March 21, and you know that because the Rockets lost last night to... Ah, crap. See, that's where it cut out. Let's go back. This was... I redid it. Alright. Let me do it again. Full moon in the day. Right there, right there. And the sun. This is March 21st. Last night, James Harden scored 57 points, 18 out of 36 field goal percentage. Lost to the Rockets. The Rockets lost to the Grizzlies, 126 to 125. And then you can also see the date stamp right here. All right. So that's weird. You know, I would expect when the sun and the moon are directly opposite and you can see them at the same level on the horizon in daytime, that, well, shouldn't the Earth cast a shadow over the moon? I mean, isn't that the way it works? Oh, when you look it up. Oh, let's look it up. And sun, same time in the day. Let's see. Earth, sorry, moon, full moon, and the sun, same time in the day. Can you see a full moon and the sun at the same time? Like I did. And they go around the full moon phase. This is time and date. The moon is visible in the sky approximately from sunset to sunrise. In very special cases, you can see both the full moon and the sun as it rises or sets at the same time in opposite directions. Okay, that's great. Why? The technical term for this alignment is syzygy of the Sun-Earth-Moon system. You know, at the precise moment of the full moon alignment, the moon is only visible in the night part of Earth with a few exceptions. They don't really tell you why. I thought they did in some place. Space.com. Wait. No. Come on. Why can't you see the moon and the sun? Alright, space.com. Maybe they can tell us. Because we have to rely on them telling us, because we can't formulate our observations on our own, apparently. At 10 o'clock Saturday morning, your local time, both the sun and moon are riding high in a clear blue sky. How can this be? Let's see. Alright, so a very common misconception in astronomy is that the moon is directly opposite the sun in the sky. In fact, the moon is only in this position for a single instant in the whole lunar month. The exact time of full moon, it was a full moon, when it is 100 degrees away from the sun. Yeah. So at full moon, the moon is exactly opposite the sun. Oh, okay, so it was in that video that I just did this morning, of course. This means that the moon rises just as the sun is setting and sets just as the sun is rising. Duh. This is also the only night in the month when a lunar eclipse can happen. But it didn't happen. Even so, eclipses normally happen only one full moon out of every 6. Oh, one out of every 6 times that lunar eclipse will happen. The other times, the Earth's shadow is either too high or too low to touch the moon. Two things contribute to the moon being visible in daylight. First, it is bright enough that its light penetrates the scattered blue light of the sky. So, the scattered blue light, that's why you're able to see it when it's not a lunar eclipse, apparently. If you're looking at exactly the right spot with a telescope, okay, all this other stuff. Secondly, the moon must be high enough in the sky to be visible. Yes, like, I wish I would have recorded it while I was driving my daughter to school, because it was much more visible. And of course, I wish I had instead of my phone, I actually had my camera, which I have lens filters, so you can actually see it a little bit better. And blend it in too well with the scattered blue light of the sky. All right, let's see. I kind of didn't read the chat, so let me get back to the chat a little bit. Full moon was on the 20th, dummy. All right, thank you, Splurge. Let's see. Okay, just a lot of conversation between y'all. That's good. That's fine. All right. So, back to Michelle Thaler. So far, the 3 proofs that debunk flat Earth theory. Well, they didn't quite. In fact, they actually set me towards flat Earth. But you know what? You know, maybe Elizabeth or Michelle Thaler, she didn't. I mean, that's only 3. She has more, right? Maybe other people have more. Let's just finish this out.
Moon. And when the moon is entirely in the Earth's shadow, the moon looks kind of dark and even kind of red colored. It's really, really beautiful. What's happening in that case is that the sun is on one side of the Earth. The Earth is in the middle, and it's casting a shadow. The Earth is casting a shadow on the moon. And as the shadow moves across the moon, you'll notice that the shadow is curved, it's round. So something like the sun that's
curved, like imagine it wasn't a globe, it was just flat. There's another object behind it, right? Oh, well, hey, it's curved. See that? It's curved. See that there's curved shadow. Obviously, what causes that curve is because it's a globe round object. What? What the heck happened? I thought this was supposed to be a globe. It cast a shadow that was curved. This, folks, is a three-dimensional object represented in 2 dimensions. Oh my goodness, why is that green? That stupid gray. Let's get that gray background out of there. I'm sorry, folks. I think that is was that up there all this time? Damn it. Anyways, you can't see that this is actually a round globe object because you guys are looking at a 2-dimensional monitor. So magic. This is actually a globe, if you guys didn't know. This is a round ball. But because you guys are watching on a 2-dimensional space, a 2-dimensional medium, you guys just see this as a flat object. But, you know, that's why flat earthers, you guys are wrong, because this is actually a ball. Now, this is also a ball, but see, this is a 4th dimensional representation in the 3-dimensional realm viewed in 2 dimensions. So this is actually flat. It's not a ball. I mean, I don't know. Like, what? You could just say a whole bunch of shit and people will believe it or they won't. So the shit that Michelle Thaler is saying, I don't believe it. So there's that.
Bigger than the Earth and is able to cast a shadow of the Earth on the moon can actually show you the shape of the Earth. Aha, you might say, but could the Earth be a disk? Could it be flat, but it's actually still shaped like a disk, not like a sphere? There was a Greek scientist called Aristarchus, and what he noticed...
Oh, finally we're down to Aristarchus. You could let off with Aristarchus. I mean, Aristarchus is the one that started it all, apparently. All right, let's see what she says.
Was that you can get a lunar eclipse at many different angles where the sun is. Sometimes the shadow goes straight across the moon. Sometimes it just kind of glances the moon. Just a little bit is in shadow, just on the top or on the bottom. From every different vantage point, every different angle that the sun is casting a shadow, you always get a perfectly curved shadow. The only shape that can cast a shadow that's curved from any direction you put the light is a sphere. So people have known that the Earth is spherical for thousands of years. It's not okay to say that the Earth is flat.
Guys, you guys hear that? It's not okay to hear that the Earth is flat. It's just thousands of years it's been that way. Don't even think about the hundreds of thousands of years before Aristarchus where people thought the other way, that it was flat. Don't think about that. For 2,000 years, folks, we knew the Earth was round. We knew. Forget about the hundreds of thousands of years that we knew that the Earth was flat. Aristarchus, folks. Aristarchus. That's it. That's all you have to know. Aristarchus, for over 2,000 years, you can't even think of it being flat because you can't think about the hundreds of thousands of years before Aristarchus, where everyone thought, hey, it was flat. So, yeah.
This is some sort of strange denial. I don't know where it comes from.
Strange denial. She doesn't know where it comes from. NASA astronauts. Just strange denial. Why do people deny it? I mean, obviously, Stephen Hawking presented an experiment. I'm sorry, observation, but they'll call it an experiment. That there's curvature, you know, where the helicopter lands and goes up over the distance. And then 3 birds ruined it, so it looks like it's fake edited video for the results. But let's not think about that. All right, and then you've got the great Eratosthenes. Okay, that was the second proof. Eratosthenes, he supposed that the Earth was curved, a globe, and he never left Egypt to calculate and measure the circumference of the Earth. He just knew. I mean, you know how those 3 birds were in that video, that they flew in the same formation over that lake? Well, that's how great birds are for carrying messages. That's why carrier pigeons were like the internet of the BC era. I mean, they just trained day in, day out, same formations, same locations. They were just reliable. I mean, your internet service provider goes down, your power goes down. Those carrier pigeons, they'll keep going. They're like the Alka-Seltzer bunny. Wait, Alka-Seltzer. Alkaline? Energizer bunny. I'm sorry. Whew, I haven't seen commercials and stuff like that for ages. Okay, let's finish this off.
From. And it's something where I keep getting this question. We really need to put this question to bed because we've known the Earth is a sphere for a long time.
We need to put this question to bed. We've known that the Earth was a sphere for over 2,000 years. And for the hundreds of thousands of years before that, we didn't. So to even think that we're going to think about things that were out there for hundreds of thousands of years. I mean, Stone Age people, come on. What age was it? 270 BC? Is that the Age of Enlightenment? When was the Stone Age? Stone, copper, Iron Age, or Bronze. Okay, let's look. Images. All right. So, I guess it was the Iron Age. I mean, I guess those other thousands of years, psh, you know, idiots. Goodness. Do they, like, I don't get the ages quite well. Let's see. 100 BC. This is weird. It's like the events are just all over the place. Before coins were made and first used, we knew Aristarchus figured it all out. That's not much here. Yeah, it was the Iron Age, I guess. Okay, the ages. Oh man, why is this so hard to read? Can't they come up with a good like age chart? I guess here Roman time periods. Damn it. Okay, Iron Age. I don't know why I even got here. All right, let's keep going. She's gonna probably finish this out in a minute 20 seconds, talking about how she just can't fathom why people think this way.
There's some even well-meaning people that have kind of, you know, they say, well, I don't really believe the Earth is flat, but I'm not really sure what to think about it. And they've asked me some interesting questions like, you know, they've heard that that space is very hot. You know, that when you go up above the atmosphere, the temperature of space is millions of degrees, which is true. The problem is there's basically no air at all. So I mean, the gas right around the Earth is actually millions of degrees hot. That's actually true, but there's almost none of it. There's almost nothing. Like one single proton whizzes by you at a temperature of 1,000,000 degrees. It's not the same as temperature, like in the air. It's not the same thing at all. So that one was one that I get sometimes. And the other one is, I actually said this to somebody and I couldn't believe they'd never thought of it, that, you know, with binoculars you can see planets. You can see Saturn and Jupiter. You can see Mars with a telescope, the sun, the moon, everything else you see in the solar system is a sphere. So we're the one.
A sphere, do they turn, spin, so that we could see, or do they look weird? All right, let's do Saturn. Saturn from binoculars. Oh, that's telescope. Okay, binoculars. 720p. It's not. Like can you tell that's spinning? You guys know that it's spinning? It's spinning very fast, spinning very slow. Is it spinning? You can tell. I could, right? I could. You guys just don't have the eyesight that I do. Let's see. Let's look at Venus is closer, right? All right. Through binoculars. Oh, obviously, it is definitely spinning. A spinning globe, I could tell. You know how I could tell? I've got super eyesight. You know when you squint your eyes, you could see much clearer. It's like perfect. Asians' eyes are always squinted. That's why we can always see better. You could see whenever like any other race they want to see better, they squint, right? Asians, we're like that naturally. So when we squint, it's like double the effect. Okay, let's see. Let's do Mars from binoculars. Binoculars. Oh, Jupiter in binoculars. Oh, well, stop that. Oh yeah. I know you guys can't tell, but it's definitely spinning. It's a spinning globe. You know how I know? I'm using my super squinty Asian eyes. You flat earthers, you guys are blind. It's obviously a spinning ball out there. I know because I said so. Okay. So that's like the typical response by a glober. 20 more seconds. Let's do it.
Thing that is different, and that actually made somebody who was more interested in actually hearing information, that actually got them to think. They were like, you're right. Everything else we take a picture of is a sphere.
I'm convinced. All right, who's convinced? Everyone. Every flat earther who's back to being a globe earther, raise your hands. Anyone? Someone else raise their hand first. Okay. All right. Again, we're not here to debunk globe earth. Let's not debunk globe earth. We're here to debunk flat earth. All right, let's flat earth crushed by Discovery Channel. All right, let's look at that. That's the second one in the YouTube search.
This lake holds the secret to the size and shape of the earth.
Oh my gosh. It's Stephen Hawking. Is this the same one? Yeah, it's the same one. Someone else found it. Except this time they're saying, hey, flat earth is crushed. And I didn't know it was Discovery Channel. I thought it was PBS. So let's skip to that part. Oh my goodness. Yeah, here's the three birds. Will they catch it? Let's see if they catch it. Let's see. Oh, this is good. All right, this person's got 3 million views. 3.5 million views. That flat earth is crushed by the Discovery Channel. Yet I've got 202 views. Or yeah, 202 views. Damn. Why do I only get 202 views, but this guy has 3.6 million views? We're just kind of covering the same thing. Yeah, let's watch.
Yeah, I have you on the telescope. Go ahead and land.
Oh, what the fuck? The three birds are there in his video? Let's see if those three birds appear I mean, I'm gonna have to call out Alex Churtnick for editing the video.
As it lands, it completely disappears from my line of sight.
Joey, are you still airborne?
Yeah. Can you see us landing?
The reports from the helicopter, they're still flying. But I can't see it. To wrap your head around it in that short a time was a little difficult for me. I was like, this is crazy.
We have landed in our position.
Okay, Joey, go ahead and lift off.
They plan to ascend until Kim can see them on the horizon. Then they'll tell him their altitude.
Let me know when you can see us on spot of the horizon.
Oh, what? Those three birds again. Oh, man. So, wait, I didn't fake this video? What? I mean, this video, this guy faked it too? He faked it exactly the way I faked it? Is that what happened? What the? That guy is a good faker. I mean, he has the same faking abilities as I do. Or wait, maybe this Discovery Channel was the one who faked it. Because, I mean, anyone could watch it and see that exactly the same two scenes happen as we're watching it now. Either on my video or on Alex Churtnick's video. Yet, this is Flat Earth crushed by Discovery Channel. While, if you watch my video, don't. Just assume that those three birds just are practicing flying formations, because it's so ingrained that they used to be carrier pigeons back in 200 BC. It's amazing. You know, once we lose the internet, we're just gonna be sending each other letters through carrier pigeons. These three birds, they've been training up, you know, they're training for that apocalypse. And of course, yeah, I know apocalypse is awakening. When was the term? Armageddon, I guess. So shit. Well, Flat Earth Crust, number 2 result for Flat Earth Debunked, was actually the number 1 proof in the first video that came up. So we are seriously hurting for debunking Flat Earth, folks. Don't blame anyone else but those three birds, because, well, it should be easy. Oh, look, I visited these top 3 pages before, it looks like, at least these 2. Okay, 10 easy ways you can tell for yourself that the Earth is not flat. This is by Popular Science. Okay. Instead of 3, they upped it to 5. I mean 10. Oh, excuse me. For the sake of, what the heck? Damn it. Silence yourself. Okay. Whew. For the sake of not repeating hell, I guess. Well, if it mentions the same thing as those other 3 or 4. Okay. All right, here we go. Top 10. Number 1, the moon. Now that's number 1 reason why the Earth is round. They're stating the moon. The Earth is round because of the moon. It's like, I know that I don't know how I can even equate this to anything. Alright, now that humanity knows quite positively that the moon is not a piece of cheese or a playful god, the phenomena that accompany it, from its monthly cycles to lunar eclipses, are well explained. It was quite a mystery to the ancient Greeks, though, and in their quest for knowledge they came up with a few insightful observations that helped humanity figure out the shape of the planet. Aristotle, who made quite a lot of observations. What? He didn't make experiments? Just observations about the spherical nature of the Earth because of the moon. Notice that during lunar eclipses, when the Earth's orbit places it directly between the sun and the moon, you know, just one of the 6 times apparently that we know now, because and if you do see the moon full without it, you know, the being an eclipse, it's because the scattered blue sky. Creating a shadow in the process. The shadow on the moon's surface is round. Again, folks, this object, this black object right here, what you guys don't realize, it is round. It is 100% round. It is a globe. Okay, you could tell because the shadow cast over on the white globe, it's curved. Therefore, this thing is a globe, and thus this thing is a globe. Don't look at it sideways. Just look at it this way. The reason why you're seeing these as flat is because the 2-dimensional medium that you're looking through is flat. If you're looking at it through a curved, monitor, then I don't know what to tell you. Okay, see, globes, curved. Proof that the shadow that's cast, you know, it's curved, proves that these 2 objects are a globe. It's proven right here in this observation. And if you don't think these are globes, I'm telling you, you guys got to start smoking some weed. All right, let's see what else we got here. Since the Earth is rotating, see the Foucault pendulum experiment. Oh man, for definite proof if you are doubtful. I wonder if they put that in like number 5, 6, 7, 8, 9, 10 or whatever. The consistent oval shadow it produces in each and every lunar eclipse proves that there is not only round but spherical, absolutely, utterly, beyond a shadow of a doubt, not flat. All right, obviously, if you can't know that this eclipse where you get that shadow to be round, right? Round, curves. This is obviously, definitely, beyond a shadow of a doubt, not flat. Do you understand that? Do you understand that, flatheads? This, beyond a shadow of a doubt, is not flat. Okay? Idiot flatheads. If you guys can't see that this is not a globe, I don't know what to do. I feel like I'm Bob, the science guy right now. Ships in the horizon, number 2. Oh, shoot. We went over that again. Except we didn't use a ship. We saw helicopters. Haha. Yeah, okay, let's skip that. Varying star constellations. Oh, okay. So we're going to look up at the night sky to see what's down here on Earth. This observation was originally made by Aristotle. Man, Aristotle, this guy knew the Earth was a globe. 384 to 322 BC. He declared the Earth was round, judging from the different constellation one sees while moving away from the equator. So, the different constellations you see proves that the Earth is round. Okay? If you don't get that, then, well, you haven't seen different constellations while you're moving away from the equator. If you see the different constellations while you're moving away from the equator, that proves that the Earth is a globe. This is number 3. Because the varying star constellations, therefore, globe Earth. Like, for example, I've got a lot of nails on the ceiling of my basement, and as I move from one area of the room to the other, I noticed that the the nails vary up in the ceiling. And therefore, I know that the ground I'm standing on is a ball. I just know that. And if anyone objects, well, you guys got to go back to astronomy classes back in your community college. Oh, actually, skip that. I'm sorry. Community college won't cut it. You need to go back and try to get your SAT scores or ACT scores up high enough so you go into prestigious universities such as MIT or Harvard, and they'll tell you what's up. Okay. Let's go to Shadows and Sticks. Oh, we're going back to Eratosthenes. We've already covered Eratosthenes. Let's see. Seeing farther from higher. So it's very similar to the horizon. You know, curvature, all that stuff. Okay. Like, point of view, flat, point of view, round. If you guys look at trees over a long distance, right? This is a tree on flat Earth. Do you guys see it? Right? This is you looking at a tree from flat Earth. Trees will always appear like this. That's not the case. The thing is, we live on a globe, right? So if you're looking at this tree over a distance, what you'll actually be seeing is a tree being like this because of the curve. So anytime you're seeing a tree from long distance, you're going to see it leaning away from you. That's how you know that the Earth is round. I see this all the time because I've got the squint, the Asian eye squint. I already went over this. Asians squint naturally, so we see better. So when Asians squint, we're doubling that effect. So you know how the movies, they have that zoom in, like someone just sees someone in distance and the camera zooms in. That's what it's like when an Asian guy squints. We're able to zoom in. So I know a lot of flat earthers, they can't see that the like if there's a tree over like a couple like 20 miles away or something like that, you're gonna see it like this. That's because you're not looking at it correctly. What you're actually seeing is a tree like this, but because of the angle that you're at looking at it, because you're also on that other side of the curve, it's gonna appear like you're flat. So don't believe your eyes, folks. Just believe me and scientists. Ride a plane. Oh, goodness gracious. All right. Oh, okay. All right, there. If you look at the windows of a transatlantic flight, you can most of the time see the curvature of the Earth on the horizon. Oh, you know what? One thing I love about flat earthers, and Red Pill Philosophy has it good. I mean, I just like watching this.
Kyrie Irving believed it to be flat.
No.
You saw this, right?
Don't get me started.
So we are not on a spinning ball.
Okay.
We're on a flat, motionless.
Oh, this is flat Earth. So you're pitching this as a serious call.
Yeah, no, that's serious.
Welcome back, my woke friends. Earth looks flat, it feels flat. The logical explanation is the Earth is flat, right?
No.
You saw this, right?
Don't get me started. And that dude who jumped out of a perfectly good balloon, what's his name? Felix
Baumgartner.
Felix Baumgartner.
It's billed as the free fall from the edge of space.
Don't get me started. He would have been about 2 millimeters above the surface of this globe. That's his edge of space jump.
And you don't see the curve of the Earth at any altitude. And then
you can see the curve of the Earth at certain altitudes, though.
Yeah, I was on a plane to get here and I saw it.
Yeah.
This morning, the Austrian daredevil plans to jump from 23 miles above the New Mexican desert. That's 120,000 feet, 4 times higher than most passenger planes fly.
And not only that, they made sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. So in the photo, you see this curvature of Earth's surface, and he said, wow, he's in space, look at that. No, he's not.
And so when I went flying from England to Africa, the curvature that I saw, would that be just something that I expected to see, and my sort of eyes made it look that way.
It was observation that showed us the Earth's curvature in the first place. And if you don't believe all of those scientists and government people for some reason, fly in an airplane and behold an inarguably spherical Earth.
At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball.
This is a man who just minutes ago was going 536 miles an hour, break the sound barrier on his way down.
Sky was totally black, you know, I could see the curvature of the Earth, so it was amazing today.
You don't see the curvature of the Earth.
I could see the curvature of the Earth.
You don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
I travel a lot and I fly a lot and I can see the curvature when I fly.
Okay, so 35,000 feet, you can see it, right? That's what you're saying?
Generally speaking, I can see a slight curve to it, yeah.
Okay, so Neil deGrasse Tyson says that you can't see it at that altitude, so I really...
This really doesn't... We have satellites.
That stuff is flat.
Oh, good stuff. I don't know. I don't know whether I need to believe my own eyes or the most renowned scientist of our modern era, Neil deGrasse Tyson. It's a tough one. Who do I believe? Do I believe my Asian eyes, squinty Asian eyes, or do I believe Neil deGrasse Tyson? Or do I believe everyone else? You know, Stefan Polynew, whatever his name is, and those two atheists. Do I believe those guys? I mean, they fly. I mean, I don't fly. I mean, the only time I've flown was from Boston to Seattle, Seattle to Boston, Texas to Seattle, Seattle to Texas, Great Lakes to wherever, Boston to South Africa, South Africa to Boston. Let's see, aircraft carrier to someplace in the Middle East to Greece, Greece to somewhere in New York quite often to Boston, Omaha, you know, quite often. I mean, I've only flown like couple handfuls of times, and every time I noticed that I could see the curvature of the Earth, but of course Neil deGrasse Tyson says I can't, so I'm either smarter than Neil deGrasse Tyson, and I should be the next scientist, or something is weird. Something weird is going on. I can't think about it. Let's keep going. So riding a plane, that definitely will show you the curvature of the Earth. That's number 6. 7, look at other planets. Yeah, we looked at other planets. We'd see this blurry, roundish object. Actually, like this object is round. Again, this is what we see when we look at the object in the sky. Except it's blurry. It's blurry. So it's blurry. But again, I'm telling you, this object is round. It's a sphere. Okay, you guys can't tell it's a sphere because you guys are looking at a 2-dimensional medium. You know, if you had a round monitor, you would tell that this is a round object. So therefore, when you see the planets in the night sky, you know, they don't appear to be rotating or anything like that, but they are. You just can't see it because you don't have the squinty Asian eyes. And also, you're looking at a 2-dimensional medium where everything that's flat looks like a sphere, or everything that's a sphere looks like it's flat. So don't believe your eyes, believe Neil deGrasse Tyson, and you'll be fine. You'll be like me. You'll be a glober who's a flat earther that thinks like a glober. Number 8, the existence of time zones. Yes, we have time zones. Therefore, that the Earth is a globe. You know, one of the best things about knowing that the Earth is a globe is knowing that we had to set back our clock. Now, here's something amazing. A clock is like this, right? You got a clock with a short hand and a long hand. Well, what you don't know is that if you turn that clock to the side, it's a globe. It looks flat when you're looking at it directly. But if you get any clock out there and you turn it to the side, what you're going to notice is that it's a globe. So time zones, clocks, they're all globes. And that's how we know what we're living on is a globe. Okay, number 9, the pull of gravity. Oh, gravity. Gravity is awesome. Look, as a scientist, I created a formula of non-gravity. The thing is, we can't measure it yet. In 111 years, someone is going to go ahead and measure my formula. Right now, it's called the Ebon's no gravity law. It's a scientific law because I have that formula and it works. The thing is, no one can measure it yet because we don't have that ability to do that yet. But that doesn't mean my law isn't a law. It just means it just hasn't been measured. So it's very similar to that of the Cavendish experiment, right? Cavendish's experiment was performed 111 years after Newton's gravitational constant formula. Okay, so that law wasn't measured until 111 years later by Cavendish. So my law, you know, it directly opposes Newton's law, but in 111 years you're going to see that I was right. Not only that, that measurement was the force between two objects, right? Now, what's interesting is about 200 plus years later, Einstein, with his field equations, you know, he shows you that gravity is not a force. So the measurement of the force from Cavendish was actually incorrect. But that formula that Cavendish used to measure, let's just look at the math. All right, so let's get over here. Right, Newton's gravitational constant, F equals gravity times m sub 1 m sub times m sub 2 divided by r squared. All right, or distance between the centers of each object. Sorry. No, all right. So that was in 1687. That became a law. Even before Cavendish measured it, right? That's capital G, right? And he was able to figure out the capital G. But and so this is the universal gravitational constant. Einstein's constant uses apparently the force between the two objects, and well, now that in 1798 that they're able to figure out that the gravitational constant was this, okay, they're able to find the gravity. Actually, they're able to find the they're able to find the local gravitational field of Earth. They've got that. What they needed to figure out was the mass of the Earth. Okay, so to get the mass of the Earth, they had to know the radius of the Earth. But they got the radius of the Earth from Eratosthenes back in 200 BC without ever leaving Egypt, because he supposed that the Earth was a globe and therefore the radius of the Earth. So to get to that, therefore, once you know that the radius of the Earth is this, you can find out the mass of the Earth is this, and therefore you get the force of gravity that is this. Okay, and to get there, all you have to do is suppose that the Earth is a globe. That's it. Done. Proved globe Earth. All you have to do is suppose that the Earth is a globe in the first place, and you already know that the Earth is a globe. I don't know what more there is, because I mean, I just proved globe Earth to you. Anyone who still thinks that the Earth is flat, I just proved, because the Earth is a globe. I wrote this formula where it calculates everything to show that the Earth is a globe, because I already injected that the Earth was a globe in the first place. Do you not understand that? I mean, how many times do I have to get that through your head? I debunked flat Earth because of gravity. You know what's funny? It's like I some people who never watch me are going, is this guy serious? Is this guy really that idiotic? You know, even when I was a globe earther, I didn't think like this. It's like I just kept looking into it, and I was like, wait a second. Let's keep going back. How did Aristarchus know that the Earth was round? Because I mean, he can't go on planes. He can't use, like, Aristarchus, okay? He didn't know the pull of gravity yet, so he can't use that as a reasoning that the Earth is a globe, right? Images from space, Aristarchus can't know that the Earth was a globe, because images from space, whatever. Let's look at time zones. They didn't have time zones back then, so he can say, hey, Earth is a globe because of time zones. Okay, so we'll have to skip that. He could look at other planets. I don't think they had telescopes back then. Maybe like binoculars or something. I don't know. I haven't looked into that. But he looked at the sky and said, hey, that thing looks like a globe. Therefore, we live on a globe. He couldn't ride a plane, right? So he couldn't know that the Earth was a globe because he can't ride a plane. He could look at point of views on Earth, the curvature. Apparently, when he had the Asian squinty eyes, where he could look long distances and see that a tree wasn't flat like this, but a tree was like this in the distance. Every tree looked like it was like this. That's what the tree looked like. It wasn't like this, but if you're looking at far away, the tree was pointing away from you. This is what a tree looked like. It's like, they're not upright, they're curved because of the curvature of the Earth. So that could be how he knew that the Earth was a globe. No one else figured that out. Stick shadows. That was after Aristarchus's time. So Aristarchus didn't do the stick shadows. That was Eratosthenes. So how did Aristarchus know? Because he didn't use the stick shadows. Varying star constellations. Well, I guess he figured out, similar to Aristotle, that looking at the night sky, because you don't see the same constellations when you move further away from the equator, therefore the Earth is round. I don't know how that works. You know, it's like me moving from one side of the room to the other. The ceiling isn't the same, therefore I know that the ground is a ball. It's kind of stretching it, but right. Ships and the horizon. Well, they didn't have the calculation of Earth's curvature, which is 8 inches per mile squared, so he wouldn't know how much curvature there would be. But he would look over the horizon, ships over the horizon, and say, "Hey, I see it just disappearing beneath the waters. Therefore, the curvature, except different days and whatever." If he had binoculars, he could see, "Hey, when I put the binoculars on, I could see that it's, I can see kind of the whole thing, right? I can't see just parts of it that I expect." You know, this is something I want to look more into, is like, when did they first start noticing things like this? I mean, they've had navies and ships for centuries, and for centuries they're going, hey, how come it disappears over that. Maybe it's flat. No, it's round. You know, Christopher Columbus. It's round. And that gets me questioning again, right? So it was pretty much, hey, Newton, back in 1687. It's because of that we know the Earth is round. But then, when did Christopher Columbus sail to America? 1492. So 1492. He's like, hey, you know, I know everyone thinks that the world is flat, but I think the world is a sphere, it's a globe because reasons. And then he found a place. Of course, they thought it was India, and then, like, did Christopher Columbus never been to India before? It's like, how would I mean, do they send someone who's never been to India before to find a new route to India? It's like, how would they know that it's India? I mean, just, you're not supposed to think. I think that's the important thing. If you're not supposed to think, because it's like, all right, we're gonna invest in this guy who's not from around here. He says that the Earth is exactly not as the Earth that we think it is. And, well, you know what? We're gonna give him ships, and he's gonna find India. We'll assume he knows what India is because we assume that he's been to India before. He just wants a faster route to India, and thus, well, he found a new route to India because the Earth was round. He came back. He found Indians. Therefore, everyone at that point should know that the Earth is round because, look, we found a way to India. They didn't realize it was just another continent. But at that point, they go, hey, look, the Earth is round. He found a new route to India. 1492. Plus a couple of years, however long it takes to get back to Europe. But then again, you know, it takes Newton, again, almost like 200 years to go, hey, no, the Earth really is round. Here's this formula. Not only that, Christopher Columbus. Of course, they know by then that it wasn't India. So maybe that's why it stopped. Maybe there are rumors around the early 1500s that the Earth could be round because of Christopher Columbus. But someone probably went and go, hey, that's been to India and saying, Christopher Columbus is a fool. He's never been to India. This is not India. These are not Indians. These are some other people. All right, I don't know how I got off on that tangent. Definitely, you're not supposed to think, folks. The moon. Oh, yeah. So the best one, right? You've got something that's a sphere. This is not just because it doesn't like spin or rotate, doesn't mean it's not a sphere. Okay, this appears to be flat because of the angle you're looking at, but this is actually a ball. And this same thing, this is a ball because it's a ball, you know, the angle that you're looking at, because you're, again, you have to believe me. See that curve, right? It looks like a crescent, the white crescent, right? Because of that, the curve, these things are balls. These things are globes. And just because you're looking at this angle, it doesn't appear to be balls, but that's okay because it can't be spheres. It can't. And therefore, Aristarchus had three good reasons to know that the Earth was a globe. He looked at the moon. He saw curves. He looked at the constellations as he moved away from the equator. I don't know if he ever did that, but let's assume he did. And that looking up definitely improves what's below you. And things that he looked over in the distance, he noticed that, you know, it wasn't, if he was looking that way, he didn't, you know, it's not, trees aren't standing straight up. He was looking that way and he goes, hey, trees are tilted. You know, these trees far away, they're tilted. And therefore the Earth is curving. And then the ships over the distance, over the horizon, right? This is the water, you know. This is what happens to ships as it goes further and further away. It goes, oops, it goes that way. See, it goes over the curve. Of course. If it's a helicopter flying over water, 3 birds are going to ruin that. So don't use helicopters to test it out. Make sure there aren't birds in the filming of the event, and you'll be fine. So actually 4 reasons Aristarchus knew that the Earth was a globe back in 270 BC. Okay, there we go. I debunked flat Earth, folks. Go back to watching space operas. Obviously, we all know that the Earth is a globe because every time you watch TV, whether it's commercials or movies, it's a globe. I mean, duh. We've been to the moon 6 out of 6 times. Don't think about the, you know, we haven't been back. Don't think about all the inconsistencies. Don't think about that we destroyed all the pictures and videos and telemetry data. Don't think about that stuff. Look, it was on TV. It happened. Case closed. Listen to your astronauts. They won't lie to you. They have no reason to lie to you. I mean, no one in the world has any reason to lie to each other. Everyone who says anything, you first assume it's the truth and don't question it. Especially if it's a banker, if it's a religious leader, especially if they have millions and millions of dollars. Government, always believe people in government. And you know, any authority figure that tells you what's going on, trust them. If they tell you that you need to give them money, you have to give them money, because they're going to tell you the exact reason why they need the money. If we need to go to war and kill people, trust them. They know exactly what's going on. You don't. It's for the security of you and your family and everyone else. Why would they lie? Why would they lie? I mean, seriously, why would anyone lie to you? Have you ever been lied to? Never, right? So why would you assume anyone else would lie? Because no one's lied to you before, right? Correct. So that's it. I hope you enjoyed this and have a good night. Thank you for stopping by.